Today we are going to discuss another inorganic NMR spectroscopy problem. Our topic is spin active nuclei. Consider this example. Here, usually find a one peak because they are in the same environment. But same peak for one peak for the phosphorus NMR. But here you can't find one peak because here the platinum has a spin active nuclei which is about 34%. 34% of platinum has spin active nuclei, which is I equal to where I equal to half, and rest of the 66% of platinum I equal to 0. So for these 34%, what will be the peak? What will be the peak? 2ni plus 1. So here 2 into n equal to 1 because there is one platinum atom. If someone told you to find out the phosphorus NMR of platinum, so for this compound, then due to platinum is a spin active nuclei and they show this kind of peak 2n I plus 1. So 2 to cancel out, it will be 2. And for this I value 2 into 1 because one platinum atom and I equal to 0 plus 1. You got 1. So there is a 3 peak, in total 3 peak appear for this compound. So what about the relative intensity of this peak? Relative intensity will be for this 34% abundance and you got a 2 peak, so the relative intensity will be 34 by 2, which is a 17%. 17% of relative intensity, and for the 66%, 66 by 1, so the relative intensity for the platinum spin inactive nuclei is 66%. So this for this one relative intensity will be 66%. We count the relative intensity because of trying to know about the peak height. So the combination of this peak will look like this. For the 66%, it will be the larger because the relative intensity is higher, and for the 34%, the peak is less, and you got 2 peak, and this 2 peak is only 17%, and this 2 peaks is small compared to this one. So this one is called satellite peak also. Now get back to the another examples, and we will see another spin active nuclei problem. So consider this example. has a spin active nuclei. Usually you found a one peak because they are in the same environment. But tin has spin active nuclei, which is for the 8.6% of tin. I value is half. And 7.6% for tin. I should use another color pen. For 7.6% for this tin, it has spin active nuclei. I feel equal to half. So for this, let's calculate the peak number. 2, n is 1 because there is a 1 tin atom, and for this 8.6% I value is half, plus 1, you got 2. For this one you also got 2 because same I value, and 2 and I plus 1, which is 2 into 1 into half plus 1, so you also got 2. And for the spin inactive nuclei, you got 1 peak. For spin inactive, 2, 1 is for tin atom, spin inactive, I is 0 because spin inactive has I value 0, plus 1, and you got 1. So the combination of this, all of those peak will be 1, 2, and 2. So there is a 5 peak. However, the relative intensity will be abundance of the peak divided by the number of peak you got. So 8.6 by 2, which is a 4.3%, and 7.6% divided by 2, which is a more or less 3%. So the peak will be like this. And the and I forgot to tell you, and the spin inactive nuclei, the relative intensity is higher because the awareness is high much compared to these two. So you got 1 peak for the spin active nuclei, which is a large one because has the relative intensity high. And you got 2 peak, which is a doublet one for 8.6%, and other 2 peak is for 7.6%, which is a slightly less than 8.6% because it has almost 3% relative intensity, and it has almost 4% relative intensity. So the answer will be this for this compound. So remember again, when you see this kind of problem, and if you have a spin active nuclei or spin active metal atom, then you have to calculate like this one. Although you got a 1 peak for the same environment, but for the spin active nuclei you got more peak than expected due to the coupling. So now we'll see another example. Now consider this example. Boron, and there is a 4 hydrogen around it. It is actually a tetrahedral structure. For the simplifications, I wrote the structure like this. Now consider this example. If someone told you find out the proton NMR of boron, what will be the answer? Here bromine has spin active nuclei, but for boron, but for boron I is not equal to half. Because 80% of, let me use another color, because 80% of boron I equal to half, not half, is it is 3/2. And for the 20% of boron, I equal to 3. So for the 80%, what will be the big number? 2 n equal to 1, because there is a 1 bromine atom, and I equal to 3/2. So the answer will be 4. And for the 20% of bromine, which has a spin active nuclei and magnetic I value is 3, and 2 1 boron atom, so for the 1 boron atom there is a 7 peak. So due to the 2 spin active nuclei, but not I value is not equal to half, so boron will show in total 10 peak, sorry 11 peak. 7 is for the 20%, and 8 for 80% there is a 4. What will be the relative intensity? For the 80%, the relative intensity is 80/4, which means 80 relative intensity by 4, which is 20% of relative intensity. And for the 20%, it will be 20/7. 20/7, which is the relative intensity of all these. 20/7, which is less than the 3%. So my question will be, there is a 11 peak, so the peak will appear like this. Due to 20% of relative intensity, so it has highest relative intensity, and there is 4 peak of highest relative intensity, and the 7, for the 7 peak, which is 20% of abundance, relative intensity will be 20/7, which is less than the 3%. The relative intensity is less, and there is a 7 peak appear, but less relative intensity, which is a less peak height. here is the peak. So the answer for the proton NMR of this structure will be this. That's for now. We will talk about another NMR, inorganic NMR spectroscopy problem later. Thank you.